Hey everyone, and welcome! Today, we are going to tackle a seriously powerful tool in math, the law of cosines. Now, I know, formulas can look a little intimidating, but just stick with me. I promise, by the end of this, you'll see how this thing is way more than just a math problem. It's a key to solving stuff in the real world. Let's jump right in.
You know this one. We all do. The Pythagorean theorem. It's our trusty, reliable old friend for finding the sides of a right triangle. It's simple, it's clean, and it always gets the job done. But there's a catch, right? You need that perfect 90-degree angle.
But let's be real, the world isn't always made of perfect corners. So what happens when you've got a triangle like this one? No 90-degree angle anywhere. All of a sudden, our old buddy Pythagoras, well, he can't help us here. So now what?
This is exactly where we need to level up. We need to go beyond the right angle with a tool that works for any triangle you can throw at it, no matter what its shape is.
Okay, now check this out. This is pretty cool when you see them side by side. On the left, our familiar friend. On the right, the law of cosines. But look closer. It literally starts the exact same way. It's like the upgraded version built for those tougher situations.
So, let's properly introduce the star of our show today, the law of cosines. This is your all-purpose, go-to formula that lets you figure out missing sides and angles in pretty much any triangle.
Honestly, the absolute best way to think about it is just like this. It's the Pythagorean theorem, but with a special upgrade. It has this little correction factor built right in that accounts for any angle that isn't a perfect 90 degrees.
So what is this upgrade really doing? Let's crack this formula open and decode it piece by piece. You're going to see it's way more straightforward than it looks.
Here it is again. Now, like we said, that first part, c squared equals a squared plus b squared, that's pure Pythagoras. We know that. The real magic happens in that last little bit.
First, the easy part. The letters A, B, and C, they're just the lengths of the three sides of your triangle. That's it. Simple as that.
Now pay attention, because this part is absolutely crucial. The angle, that capital C, isn't just any angle you pick. It is always the angle that's directly across from the side you're trying to find, lowercase c. They're a pair. That connection is everything.
And here it is, the secret sauce. This whole chunk, minus 2 AB cosine of C, this is that correction factor we were talking about. It's the part that perfectly tweaks the calculation depending on how wide or how narrow that angle C is. It's what makes the whole thing work for any triangle.
Okay, enough theory. You know the best way to really get a feel for a formula is to just use it. So let's solve a real-world problem and put the law of cosines to the test.
So picture this. You need to figure out how far it is across the lake. You can't exactly walk across it with a measuring tape, right? But what you can do is measure your distance to both ends of the lake from one spot, and the angle right there between those two lines.
So let's say we've got our numbers. We know one path is 8 miles, or feet, whatever. The other is 11, and the angle right between them is 37 degrees. This whole setup, by the way, is called side angle side, or SAS, and it's the perfect job for the law of cosines.
Getting to the answer is just 4 easy steps away. And hey, we already did step 1. We know what we've got. Now we just need to grab our formula, plug in the numbers, and let the calculator do the heavy lifting.
All right, time to put everything in its place. We're going to plug in 8 for A, 11 for B, and our 37 degrees for angle C. See? The formula is all loaded up and ready to go.
Now we just follow the math. 8 squared is 64. 11 squared is 121. The cosine of 37 degrees, that's about 0.7986. We multiply, we subtract, and we end up with c squared being about 44.44.
Almost there. For the final step, we just take the square root of that number, and boom, there's our answer. The distance across that lake, side C, is about 6.67 units long. And just like that, problem solved.
See? Not so bad, right? Once you break it down, it's a totally logical process. You've just unlocked a brand new math superpower that takes you way beyond the basics. So when do you actually pull this out of your toolbox? Well, there are 2 main times. First is what we just did. You know 2 sides and the angle squished between them. That's side angle side. The other time is when you know all 3 sides, side, 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 and you need to figure out what an angle is.
What you have now is basically a Swiss Army knife for triangles. It's the super versatile, really powerful tool that can handle almost any triangle problem you can imagine.
So now the power's in your hands. You're not stuck with only right angles anymore. You have the tool to find any missing side or angle out there in the world. So the only question left is, what are you going to measure first?